Yes, good day to you, students. I hope you are doing good today. Yes. This is we are still on trigonometry. I told you it's going to be a long. When I was doing the video, I said a long series. So because we have trigonometry is very long. So I want to take it from GSS3 down to SS3, then to further math class. So we end the entire trigonometry. Of course, we are doing a lot of videos on other subjects or other topics, but this we cannot stop on the way, and you cannot learn some and leave others. So you need to finish this series. Please, I beg you, learn to be patient and finish up the series. And please, there will be a need for you to subscribe. Please subscribe and press the notification button so that as many video that is sent online, you will access it without being linked up to it. Please, thank you. This is a very interesting WAEC question. This is a WAEC question actually. I copied it in a WAEC question. So let's see how we address this case. If theta, this theta, is an acute angle and tan theta is 3/4, evaluate cos theta minus sin theta over cos theta plus sin theta. Listen again. If theta is an acute angle, what does that mean to be acute angle? No, acute angles are angles that are more than 0 but not up to 90 degrees. So we have angle 60, angle 35, angle 40, angle 70, angle 72, angle 80, angle 81, angle 20. So those are acute angle. They are more than 0 but they are not up to 90 degrees. So if that is the case, if I'm to solve this solution now, I would rather draw first. Don't forget, this work is always on right angle triangle. I told you so. I have my, permit me with the diagram. So we have our 90 degree here. So if I'm having A and B and C, which I don't really need, my angle here is what I need, which is theta, or here is theta. Then I know tan theta, this is an acute angle. So that is what the question is saying. And I know tan theta, anything on tan is on opposite against adjacent. We have discussed that. So 3 will be the opposite and 4 will be the adjacent. So if where is my opposite here? If this is my angle, definitely this will be my opposite. We have discussed that. So this is going to be where my 3 is. Obviously, you know this is hypotenuse. That is the side facing the angle. So we have this, the side facing the right angle. So from there, we know this is our 4. To get our cos, we know it's adjacent to hypotenuse and our sine is opposite of hypotenuse. So definitely we need hypotenuse. How do we get hypotenuse? How do we get this hypotenuse? A lot of people, some lazy students, I know you are not lazy, they use the values that have been given. They use the values that are given alone, but it is not right. You should know what you need. What you need. So I am sure I am in need of this hypotenuse that I don't have. So I don't have to use what I was given. I have to use what I need. So all I need to do is to find what I need. So how do I find hypotenuse? Then don't forget, this is side, this also is side, then this is a side, this as well a side, then this as well a side. I've been given 2 of the sides out of 3. So by Pythagoras theorem, I'll be fine with it. That is opposite square plus adjacent square is equal to hypotenuse square. You are wondering, no, wait, I know this answer, not because I wrote it down, but I have told you about Pythagoras triple before. When you have 3 here and you have 4 here, definitely its hypotenuse is 5. And I said when you have 6 here and you have 8 here, definitely its hypotenuse is 10. So when you have 9 here and you have 12 here, definitely its hypotenuse is 15. I've been able to tell you that 3, 4, 5, you add 3 to this, you have 6, you add 4 to this, you have 8, you add 5 to this, you have 10. These are Pythagoras triple. Here you have 9, then this is, tell me this one to be 12, please tell me this, it will be 15, please. So with this it will be what? 12, this will be what? 16, and this will be 20. These are Pythagoras triple. This will be your opposite, your adjacent, or your opposite or adjacent, and basically this will definitely be your hypotenuse. So And I, apart from 3, 4, and 5, I gave another 3 structures, that is 5, 12, and 13. So if you go by this trend, so if you add 5 to this, you have 10. If you have 12 to this, you have 24. If you add 13 to this, you have 26. Then it goes that way. If you add 5 to this, you have 15. Then 10, 12 to this, don't forget this is 12. 12 to this, you have 36. And 13 to this, you have 39. These are your Pythagoras triples. So if you have 3 here, you have 4 here, without calculating, you definitely know this is 5. But for mark's sake, or for explanation sake, so we need to work this out. 3 opposite square, that is 3 square plus 4 square is equal to hypotenuse square now. So we have 9 plus 16 is equal to hypotenuse square. So this is 25. Let me write it very well. This is 25, which is hypotenuse square. So the root of 25 is obviously 5, like I said. So if you root the two sides, we have this is square, root the two sides, we have hypotenuse is equal to 5, like I've told you earlier. So this is 5. So it will help us to solve this work. So how do we solve now? Let's move. So cos theta will give you adjacent over hypotenuse. That is cos theta. Don't forget, cos is going to be adjacent against hypotenuse, and your sine is opposite over hypotenuse. We have discussed this. This is what they call SOHCAHTOA. Don't forget SOHCAHTOA. That is opposite, sine is equal to opposite and hypotenuse, cos is equal to adjacent and hypotenuse, and tan is equal to opposite and adjacent. So we can use this. So adjacent over hypotenuse here. What is my adjacent here? That is, this is my opposite, this is my adjacent, and my hypotenuse, so I have 4 over 5 minus sine is opposite over hypotenuse. That is opposite against hypotenuse. That is 3 over 5. So this is numerator. So I have my denominator divided by, I like to do my division this way so that it will avoid confusion. So I have my division. Don't forget, this line is still the same thing as this. They are the same thing. So to differentiate between numerator and denominator, that's why I placed the bracket there. So for my denominator, I have cos, that is 4 over 5, plus this time 3 over 5. That is the sine. So from here, by LCM, I have this one here, I have 4 minus 3 divided by LCM here 2. I have 4 plus 3. 5 in 5, 1. 1 times 4, 4. 5 in 5, 1. 1 times 3, 3. So this one will give me 1 over 5 divided by this one will give me 7 over 5. So to reciprocate this, to get this division terms multiplication, I have 1 over 5 times 5 over 7. This one cancel this, then I have 1 over 7 as my answer. So this is equal to 1 over 7. Let me rewrite this 7 very well so that you can see. This is what we have. We have series of these in WAEC. They come up with different strategies, different way of solving it. So let me give you this work. A jam series. This is a jam question, and it quickly came briefly, like it came in an objective. When you have this as an objective, what do you think? What do you think? All you need to know is, once you have a 13, 5, ratio of 5 and 12 and 13, you know if this is opposite and your hypotenuse. Why? Because of your sine. You definitely know if you have 5 and 13, you know this one is 12. Instead of jam now, instead of using Pythagoras triple, Pythagoras theorem, by Pythagoras triple, you have 12. So to have your tan theta, you know it's opposite over adjacent. That is 5 over 12. 5 over 12 is the answer to this without calculating. But if it is WAEC, who will need, if it is a theory question, who will need calculation, please let us go through the calculation carefully. You will know definitely that you have to use this to get your theta with right angle, and you were told 5 over 13, that is opposite against hypotenuse, that is 5 and 13. So by Pythagoras, we are going to have 13 square, that is hypotenuse, is equal to opposite, that is 5 square, plus adjacent square. That is this. Let me call it x, so I can have x squared like that. So 13 square is 169, obviously. That is 13 times 13. Then we have 5 square is 25. 25 is equal to x, plus x squared. So if I send this one to this side, I will have 169 minus 25 is equal to x squared. So if I subtract this row from this, I will definitely have 144. Check it. 144. 5 from 9 is 4. 2 from 6 is 4, then I have 1 left. So if I don't forget, if I want to remove this square, I root the 2 sides. If I want to remove the root, I square the 2 sides. So they are just like twin brothers and sisters. I want to root, I square. I want to remove the root, I square. I want to remove the square, I root. So x here will give me 12. That was what we have here. I mean, that is what we have here, which is 12. So to get my tangent, that my tan theta, which is opposite what over what? Adjacent now, will definitely give us opposite 5. Adjacent is 12. That is the answer. So I can now, I think you should be able to find the classwork very interesting now that I've done about 2 examples for you. If cos theta is equal to 12 over 13, find 1 plus sine theta over 1 minus sine square theta. This is very, very simple and explanatory. Don't forget, you need opposite here because sine is opposite of hypotenuse. Then you find your opposite. You should know the answer by now of your opposite, that's 5. Then you use that one against it. But I would love to see your workings. Don't jump. Just send your workings to me. Let's see how it goes to my WhatsApp. And again, please, I want to appreciate those that have subscribed already, and I'm sure you are actually enjoying the video by now. And if you have not subscribed, please click the subscription button and also as well the notification button. That is as well very important, because once we send a video, you will definitely access it. All right, thank you.